Hi guys, this Spider and my group members are Alex and Cody. We're going to talk about the performance of automated minimization algorithms, and these are the authors. The performance of the paper to pairwise equivalent state, and the algorithm that we are implemented uh, minimizes DFA faster. I'm gonna let you see where's yeah. Here's the algorithm that we're going to talk about, and I will let Corey to complete our presentation.
So as it said, one moment. As it says up here, uh, the equiv to test the equivalence of the two states. The third argument, which is k, as shown right there, actually is used to control the recursion depth, so that it can increase the efficiency as you get deeper into it. And as you see here, this is the algorithm we implemented. And now I will execute the program for you. So right here, we opened up the program and it says enter the P state. So 1 we're going to enter there. We're going to enter 2 here and then 2 here. And so then now it says the states P and Q are pairwise equivalent. And I didn't mention this right before a couple moments ago, but this program actually was designed to implement question 2 of the first exam. So that's where we are testing this program, and we actually hard-coded part of the question into that, but not the numbers that we used. So I'll end that for you, and then I'll run it again to show you that these numbers now that I'm going to run will not be pairwise equivalent. And right there, see 2, 3, 3, and states P and Q are not pairwise equivalent now. Now I'm going to pass it off to Alex to explain to you the code.
Hello, everyone. Like Corey said, this is implements question 2 from exam 1. The integers that we input into these functions are actually one more than what the states are given in the problem. Just because of the way we implemented the state arrays up here. Going through our program though, we going into main, all of our functionality is our call to our main program is in right here with equiv. That's where all the logic comes from that paper. If our recursive state is 0, which means we don't go far into depth, it just checks to see if P and Q are in the same state as each other, whether they're both in a non-final state or a final state, and returns a Boolean as such. Based from that, else if it will check to see if it is presumably equivalent, which means like if it's already been specified that P and Q are indeed pairwise equivalent, from the offset, then it will return true. If false, then it will default to down here, which it checks to see if P and Q are either in or not, or both in or not in a final state. It includes these pairs. It assumes that regardless that these two will be assumed pairwise equivalent for the time being. It then goes through an entire loop here in which it checks every possible string combination of up until like the depth k number depth, using then this k value here of a right here. It then calls equiv for each transition from P when it gets inputted with A or when Q gets inputted with A, and calls it recursively to check for each possible condition. And that's that on a combination of that. All that combination will then check to see if this is indeed pairwise equivalent. That is pretty much it for our program, though. Thank you all so much for listening. Have a great day.